Google should be untouchable in artificial intelligence. It has the researchers, it has the data, it has custom AI chips, enormous data centers, billions of users, and more money than most AI companies could spend in a lifetime. Google researchers even helped invent the transformer, the technology behind almost every modern AI model. And yet, if you care about the most important AI battlefield right now, coding, computer use, and autonomous agents, three much younger Chinese companies are moving faster than Google. DeepSeek is ahead of Gemini in important coding tasks. GLM is ahead. And Kimi K3 is no longer merely competing with Gemini. It has moved surprisingly close to Claude Fable 5, one of the strongest proprietary models in the world. In some coding tests, Kimi actually beats it. Meanwhile, Gemini 3.5 Pro was supposed to arrive in June. It is now August. The model is still missing, and Google has already started talking about Gemini 4. That has created a fascinating theory. Gemini 3.5 Pro may no longer be Google's real comeback model. It may simply be the bridge to something much bigger. So how did Google fall this far behind, despite possessing almost every possible advantage? And is Gemini 4 genuinely the model that could put Google back on top? Because once you understand what Google is building behind the scenes, the situation becomes far more complicated than it first appears. Google did not arrive late to artificial intelligence research. In many ways, it created the road everyone else is driving on. DeepMind showed the world that an AI system could defeat the greatest human Go players. Google researchers introduced the Transformer in 2017. The company began designing specialized AI chips years before the current boom. Its researchers made crucial discoveries in language, vision, reinforcement learning, protein folding, and robotics. Long before ChatGPT appeared, Google already had much of the necessary technology, but OpenAI released the product that changed the world. That was Google's first major failure. It did not lose because it lacked intelligence. It lost because it hesitated. For a startup, releasing an unpredictable chatbot was a risk worth taking. For Google, it was a threat to everything the company had spent decades building. An incorrect answer from a small chatbot is an embarrassing mistake. An incorrect answer displayed at the top of Google search can mislead hundreds of millions of people, trigger legal problems, anger publishers, frighten advertisers, and damage one of the most trusted information products on Earth. Google therefore faced a problem its challengers did not have. To win the new race, it had to risk damaging the business that had already made it one of the most powerful companies in history. Traditional Google search gives users a list of websites and places advertisements around those results. A powerful AI assistant can give users the final answer immediately. Fewer searches, fewer links, potentially fewer opportunities to display advertisements. Google was not simply building a competitor to ChatGPT, it was building a possible replacement for its own economic engine. OpenAI could attack the market with everything it had. Google had to attack while protecting itself from the explosion. And while Google was debating how quickly it could move, the rest of the industry was learning in public. But Google still has more data, doesn't it? It has search, it has YouTube, it has Gmail, Maps, Chrome, Android, and decades of human activity. Surely that should make Gemini unbeatable. Not quite. Having access to enormous amounts of information is not the same as having perfect training data. Private emails cannot simply be fed into a model. YouTube contains valuable knowledge, but it also contains duplication, copyrighted material, low-quality content, and misinformation. Search activity can reveal what people are interested in, but it does not automatically teach a model how to solve a difficult programming problem or operate a computer reliably for several hours. The AI race has changed. The first generation of language models improved by reading more of the internet. The new generation must learn by doing. A coding model needs to open a real software project, understand thousands of files, make changes, run tests, recognize that it failed, repair the mistake, and continue until the task is actually finished. It is the difference between reading every book about swimming and being thrown into the ocean. This is where the Chinese laboratories became extremely dangerous. DeepSeek, GLM, and Kimi K3 did not possess Google's infrastructure. They did not have Google's distribution, and because of American export restrictions, they faced much more limited access to the newest AI hardware. But those restrictions created pressure. Every chip had to perform more useful work. Every training run had to be more carefully optimized. Every dollar had to go further. Instead of attempting to overpower the problem with unlimited computing power, Chinese laboratories became obsessed with efficiency. Imagine an enormous company containing thousands of experts. A traditional system might bring every employee into every meeting. The newer Chinese models call only the specialists needed for that specific problem. The complete model can be enormous, but only a smaller portion works at any one moment. That makes the system cheaper to operate without sacrificing all the knowledge stored inside it. But architecture was only part of the breakthrough. These laboratories also invested heavily in training models through real tasks, especially coding, tool use, and long sequences of actions. DeepSeek proved that a younger company could challenge American frontier models at a fraction of the expected cost. GLM became exceptionally strong at coding and long-running agent tasks. And then came Kimi K3. Kimi K3 changed the mood of the industry because it was not merely another inexpensive Chinese alternative. It was a genuine frontier model. On Artificial Analysis's briefcase benchmark, which tests complicated, economically useful work, Claude Fable 5 scored 1,574 ELO. Kimi K3 scored approximately 1,540. On some front-end and long-horizon coding evaluations, Kimi has even finished ahead of Fable and GPT 5.6 Sol. Moonshot itself acknowledges that Kimi still trails the strongest proprietary models overall. But that almost makes the result more impressive. Kimi is open weight. It is considerably cheaper. It can be modified and deployed by other companies. And it has reached a level that, until recently, appeared possible only for the richest American AI laboratories. For the work that developers increasingly care about, writing software, using tools, navigating complex projects, and completing tasks, Kimi, GLM, and DeepSeek are now ahead of the Gemini models users can actually access. Google may have stronger systems internally, but an unreleased model cannot win customers. It cannot build developer loyalty, and it cannot stop users from moving to competitors. There is an exaggerated version of this story claiming Chinese companies accomplished everything without advanced NVIDIA hardware. The reality is more complicated. Export restrictions have absolutely limited China's access to the newest chips. But limited access does not mean no access. Chinese laboratories have used combinations of older NVIDIA processors, export-compliant hardware, domestic chips, overseas computing capacity, and, in some reported cases, advanced processors obtained through complicated supply networks. Kimi K3, for example, was reportedly trained with access to NVIDIA Blackwell systems, although Moonshot has not publicly documented every detail of its hardware setup. So the true achievement is not that Chinese models were created without powerful processors. It is that these companies remained competitive under much tighter constraints. The restrictions did not stop them. They taught them how to waste less. Google has the opposite problem. It possesses extraordinary computing infrastructure, but almost every part of the company wants to use it. Gemini research needs chips. Google Cloud customers need chips. Search needs chips. YouTube needs chips. Internal researchers need chips. And hundreds of millions of Gemini users need their requests answered immediately. Google said in July that it remained supply constrained even after spending extraordinary amounts on data centers. Having more computing power is an advantage. But when the entire world is requesting that power at the same time, even Google can run short. Google's second major problem is not hardware. It is Google itself. For years, its most important AI work was distributed across DeepMind, Google Brain, Google Research, Search, Cloud, and numerous product teams. These groups contained extraordinary researchers, but they did not always share the same priorities. Google finally merged Brain and DeepMind in 2023, creating a single organization focused on building more capable AI. That decision worked. Gemini improved rapidly. Gemini 2.5 was competitive. Gemini 3 was a major step forward. And when Gemini 3.1 Pro launched in February 2026, Artificial Analysis briefly ranked it as the strongest overall model it had tested. Google had caught up. For a moment, it may even have taken the lead. But the frontier moved again. OpenAI and Anthropic released stronger coding systems. DeepSeek and GLM improved. Kimi K3 arrived. And Google's answer, Gemini 3.5 Pro, did not. Recent reporting has described morale problems, important departures, competition for computing resources, and the natural bureaucracy created when one AI model must serve dozens of enormous products. A startup can organize its entire company around one goal: build the best coding model possible. Google must build a frontier model while protecting search, satisfying cloud customers, integrating Android, dealing with regulators, supporting advertisers, operating global infrastructure, and preventing failures across products used by billions. Google has more resources. Its competitors have more concentration. At Google I/O in May 2026, the company released Gemini 3.5 Flash. Flash was fast, relatively inexpensive, and designed to power agents at enormous scale. Google also said Gemini 3.5 Pro was already being used internally and would launch the following month. Then June passed. Then July. As of August 1, Gemini 3.5 Pro is still only being tested with partners. According to reporting from Bloomberg and Reuters, the model failed to meet Google's internal expectations, particularly in coding. Google reportedly changed parts of the training data in an attempt to improve it. The results were still disappointing. And that is where this story takes an unexpected turn. While 3.5 Pro remained delayed, Google began publicly discussing Gemini 4. Not vaguely, not as a distant research project. Sundar Pichai confirmed that Gemini 4 is already training. He described it as Google's most ambitious pre-training run ever. He said it will use a significantly larger base model. And he said, Google is applying substantial computing power and effort to ensure it can compete with the frontier that will exist when the model launches. Not today's frontier, the future frontier. This has produced a growing belief inside the AI community. Gemini 3.5 may now be a transition generation, a bridge model, something Google can use to improve its coding tools, agent systems, and training environments while the company concentrates its biggest resources on Gemini 4. Google has not officially called 3.5 a transition model, but look at its behavior. The Pro version is delayed, the company is releasing smaller Flash models at a rapid pace, and its chief executive is already directing attention toward a much larger next-generation system. The signal is difficult to ignore. Gemini 3.5 may be important, but Gemini 4 appears to be the model on which Google is placing its real bet. There are already claims that Gemini 4 is performing exceptionally well inside Google. Those claims should be treated as rumors. There are no reliable public benchmarks, and Google has not demonstrated the finished model. But this time, the optimism is not based entirely on anonymous posts. Google has confirmed that the model is significantly larger. It has called the training run its most ambitious ever. Pichai says he is excited by the internal progress and believes people will be pleased when the model is released. Most importantly, Google now understands exactly where it is losing: coding, long-running agents, reliable computer use, and the ability to finish complicated work without becoming confused halfway through. Gemini 4 is not being trained in the world that produced Gemini 3. It is being trained after DeepSeek, GLM, Fable, GPT 5.6, and Kimi K3 exposed Google's weaknesses. That gives Google something extremely valuable, a clear target. And if Google hits that target, Gemini 4 will not arrive as just another chatbot. It could become the intelligence layer connecting Search, Android, Chrome, YouTube, Gmail, Maps, Workspace, and Google Cloud. A competitor may have a slightly better model. Google can place its model inside the operating system, the browser, the search engine, the email inbox, the Office suite, and the world's largest video platform. That is Google's hidden advantage. It does not need Gemini to become the most popular standalone chatbot. It needs Gemini to become almost invisible, quietly performing tasks throughout the Google ecosystem. So, has Google lost the AI race? If the race is coding and agentic performance available today, Google is behind. DeepSeek is ahead in important areas. GLM is ahead. Kimi is ahead and has moved remarkably close to Fable 5. If the race is cost and openness, the Chinese laboratories are applying even more pressure. But if the race is global distribution, infrastructure, multimodal data, custom chips, enterprise adoption, and the ability to integrate AI into the daily lives of billions of people, Google remains uniquely dangerous. The company has not lost the race. It has lost momentum. It has lost developer excitement. And perhaps most damaging of all, it has lost the belief that overwhelming resources will automatically produce the best model. Gemini 3.5 Pro will tell us whether Google can repair its immediate weaknesses. But Gemini 4 will answer the question that actually matters. Can Google combine its research, infrastructure, products, and computing power into one model that feels as powerful as the company behind it? Because Gemini 4 does not need to defeat Kimi K3. It needs to defeat whatever Kimi, DeepSeek, Anthropic, and OpenAI release next. If it succeeds, Google's apparent delay may look like the preparation for an enormous comeback. If it fails, the explanation can no longer be that Google needed more researchers, more data, or more computing power. Google already has all of those things. And then we will be forced to consider a far more uncomfortable possibility. Maybe Google's size is no longer its greatest advantage. Maybe it is the reason smaller companies keep passing it. Google helped invent the AI race. Gemini 4 may be its final opportunity to prove it can still lead it. Do you believe Google is preparing its greatest comeback, or has the AI world simply become too fast for giants? Subscribe for the next deep dive.